This is a video to show you the testing procedure on the Emco stepper motor that's fitted to the Compact 5 CNC lathe, to the Compact 5 PC lathe, and to the Emco F1 milling machine. It's a common stepper motor. The only difference in the motors is that one of the motors, the Z motor on the milling machine, has a band type brake attached to it. That will be shown later on in the video. But at the moment you can see we've got a low ohms multimeter set up. I've just shorted the leads out and they're registering 0.2 of an ohm. This machine, I can't null that out, so we'll have to take that into the readings each time and deduct it. And to the left of that is the stepper motor plug that this fits into the back of the control panel. And you'll notice that the arrangement in which it's in, it's got the tapered part of the plug at the bottom. So that, and this is the drawing that we'll be checking to. This is from page 5.8 from the Emco service manual that's available within the files of the F1 and also of the Compact 5 Emco IO group files. You can see that there are 3 readings to take from each side, and they're in A1 to A4, B1 to B4. The only terminal 2 on both A and B have no connection to them. So we'll start with the B side, and we'll measure in the first instance from B4 to B1. They're the 2 outermost pins. And we should expect to see, if the stepper motor is in good condition, somewhere around the 4.7 ohms. We're recording there 4.4 ohms, so that's near enough to the tolerance that we're expecting to see. Now, if I measure between number 1 and number 3 on the plug, we should get the same reading. So number 1 is at the top, and number 3 pin is there. And we've got a very similar reading, 4.4 ohms, 4.3 ohms variable. So that's okay. Now, when we measure between pin 1 and when we measure between pin 3 and pin 4, we should get 9.4 ohms. So between 4 and 3 should get 9.4. We're getting 9.5, so we're not going to argue over 0.01 of an ohm. So they're the 3 readings that are okay on the B side of the socket plug. So we now need to measure the same on the reverse side. Well, we'll do it in the same order as we did the first side, the B side. So that's between A1 and A4, and we're expecting 4.75. We've got 4.3. That's acceptable. Now we'll go between A1 and A3, and we can expect they're the same, 4.3 ohms. Now if we go between A3 and A4, the reading we're looking to get is around 9.4 ohms. Well, we're somewhere there. We're somewhere near it. So I would say from that this stepper motor windings are okay. If for any reason you don't get good readings when you check at the plug, it would be a good idea to dismantle the stepper by taking off the terminal cover so that you can see the terminal block where the incoming cable is terminated, so that you can check there for continuity of the conductors from this plug to the motor itself. So the next step will be to set up the stepper so that you can view the dismantling procedure. This is the stepper motor from the F1 CNC milling machine from the Z-axis, the Z-axis. I've taken out the two self-tapping screws from that held the terminal cover on, so that we can move that off. So that can be put in a safe place now, ready for fitting back on. And that reveals the brake belt that I mentioned earlier on in the other video. It's hooked onto the peg here. That has to be removed, and when you move it, the spring that's attached at the other end moves it away. The purpose of that is it's on the Z function, so that when the power is removed from the stepper, it puts a brake onto the stepper spindle to prevent the spindle head dropping down and clashing onto the table. There are two screws that hold this assembly to the heatsink. I'll just take the last one of those out now and put it in a safe place. We'll turn this over carefully so that you can see you can then see the points at which the incoming cables, they're all color coded, so they're quite easy to check. You can check between the plug terminal and these terminals to check that you've got continuity on all conductors coming in, and if you haven't, then you've got a problem with the cable. You need to search that out, take one end off, cut one end off and check at that, and then shorten it up until you find the fault in the cable or replace it. If these conductors prove to be in a good condition, you've got continuity from the plug to these soldered on points, then the problem is going to be in the stepper motor. The first thing to do would be to check that all of these cables that come from the stepper are actually intact and soldered onto the posts that are on the connector. If for any reason one of those came adrift, that would give you bad readings at the socket. You would lose continuity for that field, which would destroy readings that you are getting on your meter. So if you check that they're all intact, and they're all intact, if there is a problem, you should be able to find that on the board, on the terminal block itself. You're sure to find the fault. Another test that really needs to be done is an insulation resistance to earth test. So that's a test that you would need to apply. These work at up to maximum of 50 volts. So I would say that you need to test it with a 250 volt insulation tester. So inject a voltage into all of the conductors and take that reading between that and the motor case to make sure that you haven't got any short circuits to the metal of the case itself. If you have, that will destroy the stepper driver. So if you find that, you've probably already damaged that stepper driver for that axis. So carefully reassemble. If everything seems to be in order, carefully reassemble the unit. Let's secure the top case. Push the brake pan through and pull it against the spring pressure and hook it onto the tab. Make sure that the spring is clear of the conductors and of the terminals. Fit the terminal cover back on. Make sure it goes right down to the gasket to keep it sealed, and then replace the screws back into the top cover. You can feel the resistance on the end of the shaft when you try to turn it because of the brake. It doesn't stop it turning, but it does prevent the head dropping. So if you're checking your service manual at page 5.8. 5.8. You'll find the drawing, and it gives you also the section sequence table of the step numbers, brown, red, orange and yellow. And an important notice there that if you have a defective step motor, it can destroy the 10 volt and the 40 volt circuit on the stepper motor control board. For this reason, always check the step motor before you check the stepper driver. So there we are. That's the Emco stepper motor. I hope you find that little video useful. Thanks for watching. Bye for now.